Hello students, hope you're doing well. In this video, we'll look into the next part of laws of motion, that is friction in case of circular motion. Now let's say we have a vehicle moving in a horizontal circular path, or it is taking a turn. Now when it is taking a turn, we know that there is a centrifugal force acting due to inertia of direction. Now which force is balancing this centrifugal force? The frictional force acting between the tires of the vehicle and the ground is balancing this centrifugal force. So let's try to get an expression for maximum speed with which a vehicle can take turn. So here I can see there's a car here. Now mg weight of the car would be acting downwards, normal reaction would be acting upwards. Because it is horizontal surface, I can say n equal to mg. Now mr omega square is acting outwards. Mr omega square can also be written as mv square by r because we want to find speed. So from this, what we can write mv square by r should be equal to how much? Mu mg. Or because I'm talking about maximum friction, I'll take this to be limiting friction. What is limiting friction? Limiting friction is mu s mg. So I'll write it as mu s mg. I'll cancel m and m. I'll get v square by r equal to mu s into g. Or v square equal to how much? Mu s into r into g. So v equal to under root of mu s r g. So this is the maximum safe speed with which a vehicle can take turn. Maximum safe speed with which a vehicle can take turn. So if the speed is greater than that, this vehicle will skid outside. A vehicle can take a turn, right? So this is in case of a vehicle, a four-wheeler taking a turn. Now let's try to look at what happens when we are on a two-wheeler. It's a very common sight that we see in motorbike racing, that when the biker takes a turn, he leans inwards. Now why does he lean? So similarly, when we are cycling also, when we take a turn, we tend to lean inwards. Now when we lean inwards, you can see here, whatever is you can see here, the normal reaction would be acting like this. If normal reaction is acting like this, let's say this angle that he is making with this vertical is theta, then this would be equal to how much? N cos theta, and this one would be equal to how much? This is N sin theta, right? Now, so what are the, now because he's moving in a circular path, what is happening? Centrifugal force mv square by r is acting in this direction, and mg is acting in which direction? Downward direction, right? So balancing the vertical forces, I can say n cos theta should be equal to how much? mg, and similarly n sin theta would be equal to how much? mv square by r. So I divide both of them. What will I get? I'll get cos theta by sin theta would be equal to how much? It is gr by v square. Or I can write v square equal to rg tan theta. Or v equal to how much? Root rg tan theta. This is the maximum safe speed with which the cyclist can take turn if he is bending by an angle theta to the vertical. Now here we are not considered friction because the effect of normal reaction dominates friction. Now if I want to consider friction, then what would happen? So in that case, what will happen if friction is considered in this particular case? So n cos theta equal to mg, there will be no change in that. Now friction will be acting in this direction, so the horizontal force that is balancing mv square by r would be n sin theta plus f. So I can write, if friction is considered, the first equation remains same, n cos theta equal to mg, it doesn't change. Then n sin theta plus f would be equal to how much? It will be equal to mv square by r. But we know that f equal to how much? Mu into n. So that will imply n sin theta plus mu into n equal to mv square by r. Now let's write the other equation here, n cos theta equal to mg. If I divide both of them, what will I get? N cancels, I'll get sin theta plus mu y cos theta equal to v square by rg. or what will be V? V equal to under root of Rg into sine theta plus mu by cos theta, right? So this is the maximum safe speed with which a cyclist who is bending by an angle theta to the vertical can take the turn. So this is so you can see that this velocity or this maximum safe speed is greater than root mu Rg. That was when the cyclist is straight. Now let's apply the same thing in case of banking of roads. In banking of roads, what will happen? The vehicle cannot bend like a cyclist. So what will happen? The roads are elevated on the outer surface so that a component of normal reaction provides the necessary centripetal force. So here you can see that a car is moving on a banked road. This is the outer surface and this is the inner surface. So this is how N is acting. As usual, mg is acting downwards, mv square by r would be acting outward. If this is the circular path, then mv square by r would be acting outward. First, let's take a situation where we don't consider friction. Then what I can write, this is theta, so this would be n cos theta and this would be n sine theta. So balancing horizontal forces, I can write n sine theta equal to mv square by r. And balancing vertical forces, I can write n cos theta equal to mg. Dividing both of them, I'll get tan theta equal to v square by rg, or v equal to root rg tan theta. So this is the maximum safe speed with which a vehicle can take turn when friction is not considered, right? So you can see that the maximum safe speed is definitely greater than mu rg. So that is why we have banking of roads on highways where we have turns. Generally, we don't see banking in the cities because the vehicles are not allowed to go at such a great speed in cities. So even without banking, they can safely take the turn. Now let's look at the expression for velocity when friction is considered. So if I'm talking about maximum speed, the tendency of body moving away is more. So friction would be acting like this. So if this is theta, this would be how much theta? This part would be f cos theta, and vertical part would be f sine theta. As usual, this would be n, and the word this is theta, so this would be n cos theta and this would be n sine theta, and outward force would be mv square by r. So let's balance horizontal forces. So I can say n sine theta plus f cos theta. N sine theta plus f cos theta is mv square by r. And vertical forces, what I can write? N cos theta minus f sine theta equal to mg. N cos theta minus f sine theta equal to mg. I'll replace f by mu n. If I replace f by mu n, what will I get? I'll get n sine theta plus mu n cos theta equal to mv square by r, and n cos theta minus mu n sine theta equal to mg. If I divide these two expressions, what will I get? Dividing n cancels everywhere. I'll get sine theta plus mu cos theta by cos theta minus mu sine theta equal to how much? V square by rg. I'll write this expression in different form. I'll divide by cos theta the numerator and denominator. Then I'll get tan theta plus mu by 1 minus mu tan theta equal to v square by rg, or I'll get v equal to root of rg into tan theta plus mu by 1 minus mu tan theta. So this is the maximum safe speed with which a vehicle can take turn on a banked road when friction is considered. So in this way, banking of roads is helping us to take the turn with a greater velocity. Hope you could follow this. So this one, this letter is mu, this letter is mu. So what all things we have seen? We have seen how friction helps us in taking turn even in horizontal surface or in let's say, or when a cyclist bends or when the roads are banked. So this is what is there in friction. Hope you could follow this. Thank you very much.